The ones that were uploaded at the very last moment were not the ones that were written at the very last moment. So, go figure. Tab. So anyway, back to share slides. And the Chromebook is behaving oddly, so hopefully we'll get something useful. So Ronnie is taking notes in the Etherpad. If you have a second person to watch that same Etherpad and fix anything he overlooks, would not be a bad thing. If anybody wants to volunteer. Bo, okay. And since I have far too many laptops on the table, I can't actually pay attention to the Jabber. So if anybody, we do have remote participants. So if anybody want to be in the Jabber room, anybody own a Jabber client that still works? What? I can keep an eye on it. And anyway, and yeah, Bernard will be presenting remotely, so we need to actually. So blue sheets should be going around. Maybe you've already gone around. If you don't see them, figure out where they are. We'll figure that out at the end. And we have Fido recording. Note well. Note it well. The word wrapping here is fascinating, but the content should be correct. It's the old version. Oh dear. Well.
It's the old version.
Look up the. Oh yeah, I think this one doesn't have the ombudsman stuff. So find another slide deck and note that well. Agenda. Yes.
The amount of maintenance traffic we have on IETF, that's really easy.
Yes, right. So, our agenda, which has been had several things added to it at the very last moment because we discovered we had more to talk about that people didn't tell us about but hopefully we'll actually get through it all. And we have no new published documents since last time. We still have 3 things that are sitting in cluster 238, which hopefully should clear real soon now. One thing that's blocking in another document of ours, which we'll be talking about. We have removed multipath RTP because nobody was interested in working on it. We can, if somebody does come back and is interested, we can resurrect it. We had, we'll talk about frameworking on the next slide, and multiplex guidelines. Does anybody want to say what the status of multiplex guidelines is? Who's actually writing that? Is that Magnus?
Magnus.
Yeah, Ronnie, you're the editor now, aren't you? So I think it sounds like both Magnus and Ronnie thought the other one should have done something on it. I think, yeah,
This is Ben. I'm hearing that Ronnie and Magnus are going to get together, talk about it, and report back.
that sounds like an excellent plan. So, all right. So, frame marking. Yeah. Okay. So the authors on multiplex guidelines will talk this week and figure out what to say. Frame marking, is Mo here yet?
Nope.
Mo is not here yet. So Mo pushed an update. I think at the day after the draft deadline because of GitHub was down, even though he's not in GitHub because I nagged him. This is following the working group last call. So people who had comments in working group last call, which is I think mostly me and Magnus, should read over the changes and see if our comments were reflected and follow up on the list. Oh, I think I see Mo outside. That looks like a Mo silhouette there.
Oh, he left.
I think he's going to the other door.
Okay.
Somebody make sure the door isn't. It is Mo.
Oh.
Excellent. Just in time. I'm talking about frame marking.
You want me to go first? So we had feedback from Magnus, Jonathan, Ronnie, and I think maybe one or two other folks. And so we updated all of that feedback in
No, this is
08. And that should be the end of all the feedback the authors are aware of. So I think we're ready to progress this. Most of the changes were editorial. The one I should probably call out is there was a TL0 pick index. There was a note that it was valid to have 0 as a valid running index. And so there was a question about whether or not, if it's unknown, is it valid to still mark it as 0? And so we updated the text to say, if it's unknown, you actually must omit it so that a receiver can be aware whether it's truly unknown or
the short form, or what does omit mean?
Omit we actually clarified the text to say omit means a reduced length. So omit means truly remove it and reduce the length field. So it's not in the payload at all. There was also a point about LRR since we updated the restriction frame marking that you can only use it for temporally nested streams. So LRR, temporal layer refresh, is really never needed because the streams are always self-refreshing because they're nested. But that raises an issue: that is this restriction okay for future needs? And I'm aware of a few. I'm aware of some work that is not planning to do nested streams in the restrictive way that frame marking currently says. So to me, that's the only open issue, whether or not people have an opinion of, is that too restrictive or not?
So I feel like sort of what the question is a little bit vague. So would you be able to send Nell to the list sort of describing what that open issue is, so we can make sure that we have, because unfortunately what do I say? I feel like there's some concern that this doesn't solve all the problems people have. And the question is, does this solve some of the problems that some people have and is still useful, or does it not solve enough problems for anybody and is thus a waste of time or needs to be enhanced? So I think that's the big.
Exactly. Yeah, we don't want to progress this if then we have a BIS, 6 months later, because a new payload format wants to do, or even existing payload formats want to do, more elaborate markings, more elaborate structures, scalability structures. So I'll send an email to the list about what the issues are, but all the other points are mostly editorial, so I don't think they really need any discussion.
Right. As I said, anybody who had working with us call comments, please look at this to make sure your comments were addressed successfully. All right. And I think that's the end of the share slides. So, how does this work? All right. And what's up next is the CC feedback. Which is Colin. What's that?
You got on time.
Yeah, no, it's more that I thought we'd actually talk about actual working group documents before we talk about future architectures.
We can do that. The pink box seems to have turned into a pink cross, which I'm not sure is an improvement. All right. So, hi. I'm Colin Perkins. I'm going to talk about the congestion control feedback. So this is a joint draft with Zahed, Varun, and Michael, but none of the co-authors have seen these slides and commented, so this is entirely my fault, and blame me for anything that happens.
Or possibly mine,
or possibly yours, yes. We have the problem with the pink box is that you can't see the slides.
Here, you see that?
No, that's
No.
a completely blank screen.
Oh, yeah, we should have them do something with that.
Yes. So we have the congestion control feedback draft, which we've discussed a bunch of times. This is the outline of the format. I think the only change which is going to happen is that the NSEC plus one is going to turn into a length field at some point. I think we discussed that at the last meeting. Jonathan and what was it, Neil, and I think we had someone remote, Sergio remotely. We're trying to implement this at the hackathon over the weekend. And Jonathan sent some feedback based on his experiences, or I guess their experiences.
Well, my email was entirely mine, basically.
Okay, yes. So what I've got in the rest of these slides is basically Jonathan's email copy-pasted into a bunch of slides with some discussion points, so we can try and figure out what to do about those comments, since we're all in the room. So the first issue Jonathan raised was that the parsing of the feedback packets is a little odd, in that the only way you can tell if you've got to the end of the packet is that you only have 4 bytes left. And there's no actual count of the number of feedback reports in these packets. You've got an SSRC and a bunch of report blocks, then an SSRC and a bunch of reports. Then you just realize you've just got the timestamp left, and that means you've got to the end. And this is possible, it's unambiguous to parse, but it's a bit weird, and it's perhaps a little bit of a nuisance. The problem is there's not actually a lot of space for a report count, right? We could stick one at the beginning of the packets, that misaligns everything and is ugly, and I think also conflicts with the standard for congestion control feedback packets, which wants the SSRCs and everything lined up. So that would be gross, but we could do it if we needed to. We could maybe shrink this report timestamp field and put a report count in the very last offset, in the very last octet, which would also be ugly, but perhaps in a different way. Or we could just not worry about it and say that parsing is going to be a little bit awkward, but who cares?
Jonathan Lennox as an individual, I would be inclined to say the latter, but point out in the draft that parsing is a little awkward, so this is what you have to do.
Yes, yes. The advantage of putting it in the last octet is that one of the comments later is that the report timestamp field is has too much precision anyway, so we probably can spare the bits to save a byte there. But it maybe isn't worth the trouble. I don't know. So anyone else has opinions?
Niels Ohlmeyer, as the other one who tried to implement that at the hackathon, I agree it's like a little bit awkward, but I wouldn't bother too much about it. I mean, like your while loop is like, instead of saying like while greater 0 is like while greater, however you count the bits, basically.
Yeah, while length remaining is different to 4 or whatever
Yeah,
it is. Yeah,
exactly.
greater than 4. Yeah. Fine. Okay. So I guess the outcome for this is that we leave it as it is.
Yeah, with possibly some additional explanatory.
Add some text. Yeah. Okay. All right. Timing. So the current version of the draft says that the timestamps used for the report time, the clock used for the report timestamp is derived from the same clock used to generate the NTP timestamp in SR packets. And it seems Jonathan is not desperately thrilled by that choice. So this was a change made fairly recently, in that previous versions of the draft didn't specify what clock was used. And we obviously need to specify something. And I thought the NTP timestamp format was a good format, and that since we had a clock specified for sender reports, it was easier to reuse that. I certainly think the timestamp format is a good one. Whether we need to specify that it's the same clock or just a stable clock running at the requisite rate. If people think a different clock or any clock at the rate is used, I don't know. I thought it was useful that we have an unambiguous reference to which clock to use, but maybe that doesn't actually matter in practice. I don't think it makes sense to use the media timestamp here, since there are a bunch of different clock rates. I think we want something more consistent than that.
Yeah, especially because you have to be consistent across sources.
Yeah, yeah. Yeah, so it needs to be some sort of wall clock. If we want to decouple it from the clock we use for sender reports, I don't object, but we need to specify what clock we do use.
Yeah. So again, as an individual, I'm not going to be standing up because
Yeah.
there's a lot of stuff on the floor.
Cables and all
Yeah.
that.
So yeah, my main concern is that typically your NTP timestamp will come from something like the POSIX clock real time, if people are familiar with that, which is basically get time of day. Whereas for send timestamp, which is thus, subject to adjustments as, NTP kicks in or, somebody discovers their clock is off if they're not NTP synced or things like that.
Mm.
Whereas typically for feedback, you want something much more like clock monotonic, which is not have any sort of sync to anything in specific, but will be much more stable. It's on most platforms. It's usually just uptime since boot. Magnus?
Magnus Westland. Yeah, it seems reasonable to specify that this is stable, and maybe we could even reference some of the clock formats that actually would work in, for example, the clock source document, etc. Or
we want a stable clock for the sender reports as well, otherwise the lip sync goes off.
Maybe this is a bigger problem with sender report timestamps.
Yeah, okay, but yeah, I think it would be sufficient here to maybe point out that for using a clock that has any kind of clock adjustment, it has this downside that it may results in the discontinuities in the time measurements here. So, and maybe recommend saying choose a clock that doesn't have this property, and that should be sufficient for this document. But maybe we can even reference some of the reasonable clock formats if they're available based on the clock source draft. So.
If you have any suggestions for text, that would be appreciated. And if not, I can just say, well, it should be a stable wall clock in NTP format. Well, something counting, the actual sort of time of day in whatever the
when I hear
format
wall
NTP
clock,
uses.
I think that means this is current UTC time.
Yes.
Which is not what you want.
You don't.
It doesn't have to say this. This clock doesn't have to say that it's currently, November 2018. It just has to be.
Well, it does if we're using the NTP format. It doesn't necessarily have to be accurate.
Well, what does accurate mean? If I'm counting, if I say that it's January 1st, 1970 instead, because I'm counting from.
No. Yeah. Well, this is why I aligned it to the SR timestamp, because it's unambiguous for what it should be. But
yeah, I guess the main thing is there ever any interesting reason to correlate these timestamps to anything other than each other? I mean, is there a reason why you want to be able to say when this feedback message was generated versus a SR timestamp? Or do these only need to be relative to other CC feedback messages?
I don't know. My guess would be that people are going to, at some point and for some random reason, decide to compare them with the timing of all the other things which are timed. Even if we can't think of a reason to do that now. But I don't have a reason why you would care about that currently.
So I guess open issue for now.
Okay. All right. Similarly, since we're measuring the report timestamp in NTP timestamp format, this gives 65,536th of a second as the clock unit, whereas the arrival time offset is in 1,024ths of a second, and clearly one is more precise than the other. We could save some bits. We could adjust the timestamp format. I didn't think it was worth the effort to come out with a different timestamp format, but if people really care about the difference in precision, then we could change that.
Yeah, I mean, I basically just thought this is ugly, and we're basically these 6 bits. It's 2 to the minus 16th versus 2 to the minus 10th, I think is the numbers. And basically, these are 6 wasted bits of data which don't give you anything actual useful information for the.
And this is certainly true.
Yes.
Yeah.
So it feels like we could do something better, but I don't have a specific suggestion. I mean, I believe the previous versions of the draft basically had everything measured in milliseconds.
Yes, right.
Which both the absolute, both the report time and the absolute time.
Yeah, I mean, we could count milliseconds since the start of the session or something. It's perhaps a little ambiguous what the start of the session
Or
is.
milliseconds since, I mean, milliseconds since some arbitrary time, some arbitrary time that's consistent among a given sender, but other than that, nobody, you don't care.
Yeah, we could certainly do that.
Mhm.
Yeah. I don't know. I'm not sure it matters. You know, if we pick an arbitrary time, we should be clear that it's arbitrary.
Yes.
But,
I'd allow this, John. Is it a point to stop messing with this? I mean, I'd like to see changes stop at some point.
yes. Equally, if people implementing it sort of are having trouble implementing it, then we want to make it easier to implement. But I don't know. Is this issue worth revising the format, or should we just not care about those bits? Nobody cares. All right. Okay.
No action at this time. Leave alone.
Conclusion: no action.
Leave as is, yeah.
Yes. Yeah. I mean, I could specify the last 6 bits as 0 if you don't care, but you know, it doesn't matter. But I think it matters. Yeah. Okay, so what value should be used for the arrival time offset for packets that arrived after the report timestamp? So I think this is the case where we have so many packets that we need to split the reports into 2. Is that right?
Or rather, so I mean, I think for this to happen, you have basically your reporting interval has to have gotten so long that you're overflowing the arrival time offset.
Yes. So there are some packets which you know have been received.
Yeah.
But they don't fit in this particular report or something.
No, it's not that they don't fit in the report. It's that their arrival time doesn't fit in can't be represented in the arrival time offset. Given that the arrival time offset is epsilon under 8 seconds, this basically requires your reporting interval to have gone above 8 seconds.
So this says after the report timestamp. This is one's
Yeah. So basically, what this would mean is that and also things are packets reordered by more than 8 seconds, essentially.
This is packets which are in the future for a particular report.
Right. So you have to use at the time you get around generating the report, you discover some of the packets, their arrival timestamps are more than 8 seconds ago. So you need to generate 2 reports.
So that's not. I'm confused.
But I think the conclusion is right anyway.
Okay, right. So yeah, we need to clarify exactly what's here so we can write the guidance. But I think it's we mark them as not received at that point. Okay.
Which that's related to this. It's related to this other point too.
Okay, so the second point is what actually is the timestamp in the what actually is the report timestamp?
Mhm.
And currently it says the time instant when the report packet was generated. Hang on, yeah. I'm confused.
Yeah, so this is the same issue as previously, that the time the report was. So if you discover that you can't represent, you've got more than 8 seconds of packets to report.
Yes.
So one of them you have to pretend that you generated this report 8 seconds ago, so that you can represent the arrival time offsets of the oldest packets.
Yes.
Then the report timestamp will not be when this report was generated, because that's now.
Yes.
But you're faking it as being 8 seconds ago.
Yes.
So it's as if, and then you were generated as if it was generated 8 seconds ago, but then I think it's mostly just semantics of what
Yes, right.
But the point is, you can't rely on this for things like RTT value, or, RTT estimates or anything, because it's not. It's it's the time at which this report is true, or this report was true, not the time at which.
Not necessarily the time at which it was generated.
Exactly.
Yeah. So it's what it probably wants to be is the time at which the last packet in the thing was received, such that the arrival time offset for the last packet is 0.
It doesn't have to be.
But that would be a clear and unambiguous definition.
Yeah, but the tricky thing there is that because you're reporting over multiple sources, that means you have to scan all your sources before you can figure out what you're.
Yeah. Okay. Yes. There is a time which indicates the point at which you are reporting on.
Yeah.
That doesn't necessarily represent the time at which the packet was generated. I think that's the thing we need to be clear about.
Exactly. Yeah.
Because it could be a time in the past.
Mhm.
Yeah. Okay.
Does anybody
Is
other
every-
than me understand this? I'm not even sure the caller understands it.
yeah, me neither. So there is a report timestamp in the packet. So it currently says it is the time the packet was generated. I think we decouple it from that. We say it's the report time.
Yeah.
It may be in the past.
This was the state of the world as of this time.
Yes. Yes. It would typically be the time at which the packet is generated, but it may be a time in the past.
Right.
Niels Omer. But the whole problem only arises for the scenario where you generate a report for the past.
Yes.
Otherwise, the assumption is always that this is like now.
Yes, but there's corner cases where you have to generate something for the past in order to correctly represent when very old packets arrive.
So I guess actually what it may be is if you have more than one, if you have so many reports that you need to have more than one report packet, then it may be a time in. Yeah, some of them may have times in the past.
Yeah, I think so.
Yeah. Which is rare and should only happen if things get reordered in weird ways.
Right.
Or either things get reordered in weird ways, or if your group size is huge and your RTCP bandwidth is small, such that your reporting interval gets really, really long.
Yeah.
And in that case, you might not even set the reporting timestamp to like in the 8 seconds interval, but you was probably for like the one where you generated for more the 8 seconds, you probably set the reporting timestamp right at the earliest possible time of the extra packets you need to report.
Yeah,
right?
Something like that. Yeah.
Okay. Yeah. So I think we need to explain that there are odd corner cases where you have many packets to report on and the intervals don't work, where this may not be the actual generation time.
Mhm.
Yeah. Okay. Fine. Okay. Overlapping reports. Okay. Yes. So we need to just do the right thing with very old packets and not report them as lost, but report them as being out of range if we can put them in. Yeah. So that's just a straightforward clarification. Okay, so we currently say that consecutive reports should just be consecutive sequence number ranges and should not overlap. Obviously, if you have a big outage, then you don't want to send a report on the last 10 billion packet or 10,000 packets which were in the outage. So we need some words to say do something sensible if there's an outage. And that's just a bit of wordsmithing, I think.
And then there's also this, because my email was sort of incoherent, there's also the converse case here that if you had packet, sometimes you'll actually get a slight overlap in reports. If you had, say, packet reordering right at the point you sent a feedback,
Sure.
you want to actually go back and say, hey, yeah, so I previously reported through packet 7 saying packet 6 was lost. Now I'm reporting saying packet 6 arrived. And yeah, packet 7 still arrived, and that's the same time.
So there's some overlap.
Yeah.
Okay, so again, that's just a clarification of exactly what to do in a bunch of corner cases. Yeah. Reports on duplicates. If you get a packet and if you get multiple copies of a packet, which one should you report on? I suspect it doesn't matter. My gut feeling would be to say we report on the last copy of the packet received, but if you want to make it first, I don't care.
Yeah, I mean, I think last is probably
Most recently received packet.
And
with
in particular, if you happen to get a duplicate packet after, you report on a packet then you get a duplicate of it again after you sent the report. You should probably send an updated report with the new arrival time
In the next report.
in the next report, yeah.
Yeah.
Which will again have an overlap period. Though.
Yes. Okay.
Were you saying something, Ronnie? Or?
So you reported also the same one?
Yeah.
With the previous times?
No, with the new timestamp. With the new timestamp. No?
Mosin had it. From the implementer's point of view, yeah, some of these things are confusing and weird, and it seems like we're just coming making up answers that sort of make sense for an implementer. But I mean, the point of all this is for a congestion control implementer, and so I'm wondering if any of these decisions are actually impacting how the congestion control algorithm actually works. Like, do congestion controls expect feedback on duplicates, and do they expect accurate feedback on the duplicates? And if we make a decision about it's going to be the first or the last, wouldn't that impact their algorithms? Because they're using these numbers to actually calculate the available bandwidth, right?
Right. So probably we should bring this up in our MCAT also.
Yes.
Some of these more concrete issues, things like that.
My guess would be that duplicates are rare enough that it doesn't make any real difference in practice. I suppose you might hit corner cases where that's not true.
Well, there's two reasons for duplicates. One is that you really do have the network replicating packets, which is pretty rare. The other is people who don't implement RTX properly and just respond to that by resetting the same packet. But hopefully we can convince them to stop doing that now. This
is the one. This is the one that actually made me think about we really need to bring this up to the congestion control implementers. The other ones may also be relevant, but this one immediately struck me as that if I was implementing the congestion control, I would want to know the first packet received, because the deltas that I'm calculating and the delivery offsets that I'm calculating, the duplicates are irrelevant to me. It's really the first one because if you start giving me reports on the duplicates, those are going to probably skew my calculations. So I think the earliest one is the one that probably makes the most sense for a congestion control implementer.
No, I mean, you're right that we should probably bring it up for the congestion control people. Yeah, certainly. Yeah, I thought about that. Okay. Okay, which SSRCs do you report upon? It currently says report on every SSRC that's being congestion controlled. The issue is, of course, the receiver can't tell which sources are being congestion controlled, so you should probably just say report on every active SSRC. Okay, that one's easy. Signaling, RTCP feedback SDP negotiation allows you to limit feedback to a subset of payload types. Should that be allowed for congestion control feedback? Well, I hadn't realized it did that.
I only realized this because when I went to try to interoperate with Nils, he set the signaling that way.
Okay. Yeah. I can imagine weird corner cases, like, for example, if you're sending variable bitrate video along with low rate constant bitrate audio, you possibly don't care about reporting on the audio for congestion control because you can't congestion control it anyway. The only congestion control is just to stop sending it. And if you have 10 kilobits of audio and 5 megabits of video, who cares about the audio congestion control? So maybe you might want to do that. But
yeah, I mean, I think in this case, it's this should apply to your RTP transport, not to the actual codec, right?
Yeah.
This is agnostic of the codec, but
yes,
the RTCP feedback specification is. I mean, yeah, you showed me like the implementation with star, I guess. I mean, the question is if that needs to be written down here in the draft to say like it always needs to be happening for all the codecs you're offering.
I mean, I can certainly imagine cases where you have codecs which you can't congestion control, and there's no point sending congestion control feedback for.
Well, no, because you can still may not be able to congestion control those, but you still know how much congestion there is on this whole session, and you take away bits from the things you can congestion control.
Yeah, sure. Yeah. But I mean, if you're sending video and you have a very low rate text channel or something, then why bother sending congestion control feedback for the subtitles? Because they ain't going to make any difference.
Hello, John. And the reason we started out on this stuff was because we needed transport-wide congestion control. Implementing the mechanism in such a way that you can usefully use feedback on only a few packet types in the session is going to be severely complicating implementations and make it less useful for what we set out to do. So I'd strongly, at least strongly, suggest that we just say report for everything all the time.
Yeah.
Don't, and implementers should not have to care about the case where the implementers of the sending feedback should not have to care what the other side does with it. That's the whole point.
Yes, I mean,
And the sender has to sort out, yes, I'm getting packet loss, and now I have to allocate bandwidth between the text channel and the audio channel and the video channel. That's the sender's problem.
Sure, but it's the sender's problem in this case as well.
Yes,
you're just
but
telling the
if
receiver
you
where to send, which sources to send feedback on.
no, if the sender is only able to say I want feedback on everything, then the receiver only has to implement support for sending feedback on everything.
Yes. What we're not saying is the receiver has to care what the sender's doing or which source is being congestion controlled.
No.
All this is saying is you've some streams you just omit the reports on.
I mean,
the problem is not per stream, it's per payload type, which is particularly annoying because sources can interleave payload types, and that gets really complicated.
I mean, if you specify for some media sections and not others, well, that's something you can do with SDP. That's sad, but I think you should. I think that the use case we definitely want to support is congestion control for a whole transport, and anything that makes that life more complicated for implementers should go away unless it has a compelling use case.
Okay, so we just specify that you have to specify all payload types.
Yes.
Yeah, and if you Niels Omer, and if we agree on doing that, then I would suggest that to make it life easier for implementers, to mandate that you basically use this in SDP with RTCP feedback star, to avoid the situation that what I basically sent Jonathan was the list of like, here are all the payload types, and I'm listing it on all on one, because if we allow that, then you actually need to require from the implementers to go through all the payload types and ensure that it's actually turned on for all of them, and handle the corner cases of like what happens if it's not offered on one of them. So I think the easiest solution then is to just say like it has to be done with star.
Okay.
End of story.
Okay, sure, that makes sense.
So as a consequence of this means that all retransmission formats and FEC formats would also be mandated to give feedback. Receivers would have to feedback for every RTX or
That
FEC
would be a
packet.
consequence of it, yeah, unless you did them in a separate section. So
Yeah. I mean, we need to figure out, I mean, separate section is a whole other thing, but I mean, I think you want that because you want to get feedback because again, you want to figure out how much total stuff is getting through on the session, and obviously what's experiencing congestion, which particular SRCs experience the congestion does not have to be which SRCs you adjust, to reduce or increase your bandwidth. It's entirely up to the sender how those associate. But I think absolutely sending the feedback for all the repair flows also is absolutely what we want.
It may be worth explicitly calling that out because that may not be obvious to an implementer.
okay, yeah, makes sense. Okay, yes, we should fix the editorial nets. Okay, I'm done. Thank you.
Okay, great. Thank you. And who do we have next? Bernard?
Bernard, yeah.
Bernard, okay. So Bernard, if you want to get in the queue, so you can talk.
Can you hear us?
There we are. And let me get,
Yeah.
that's this one, right? No, not that one. It's RGB,
Audio.
quick multiplexing, this one.
Not.
Quick multiplexing, right.
There we are.
So can you hear me?
Yes.
Oh, okay, cool. All right. This is a presentation about quick multiplexing. It's a follow-on to a presentation that Cullen made at IETF 100. So we're going to give you an update on where we are and what I'd like to recommend the group do from here. Next slide. Okay, so just recapping the problem, Quick is potentially attractive as a peer-to-peer data exchange mechanism for WebRTC applications. Primarily, that is reliable transport, which is defined in the current Quick transport document, but there have been some interest in unreliable transport for things like games or potentially media. And people are proposing unreliable datagram extensions to Quick. WebRTC applications almost always multiplex today, and that's RTP, RTCP, STUN, and DTLS all on the same socket, very, very popular. That's currently documented in RFC 7983. So in terms of solutions, multiplexing of STUN is absolutely required because otherwise you'd have to reinvent some equivalent mechanism to do peer-to-peer. Multiplexing with DTLS, SRTP, and SRTCP is required if you're going to do use RTP, SRTP, and SRTCP alongside Quick. And if you can do that, you get also the ability to mix Quick and the SCTP, DTLS, UDP data channel as well. Next slide. So some non-requirements are support for turn channel multiplexing. That's an optimization which I believe is not supported in any WebRTC implementation where you have a 4-octet prefix instead of the standard 36-octet stun overhead. Also, ZRTP is used in WebRTC as far as I know, and that's an alternate key exchange mechanism. So we don't require that these actually work, although it's okay if they don't break them. Next. So a little bit of a recap of past events. On March 2017, Colin Perkins and Lars Egert first noted compatibility of Quick with RFC 7093 and filed an issue. In November of 2017 at IETF 100, Colin presented to IETF to Avtcore a potential solution. On November 29th, that solution was proposed as a PR and merged into Quick Transport 08. And subsequently in December, a PR to undo the changes was rejected. And as I'll describe, Quick has evolved since then. And so the solution proposed by Colin has changed a bit. And we'll talk about some of the implications of that next. So this was the demultiplex proposed at IETF 100. The main differences here are that there's potentially some overlap between Quick and the turn channel, but as I mentioned, that isn't really consequential because WebRTC implementations really don't support the turn channel. And then Quick is also in the range 250 to 255, which is the long header. So basically, this meets all the requirements and some things that were non-requirements, like not conflicting with ZRTP. Next. Okay. Now, a few words about the DTLS allocation here. It's important to understand that currently DTLS does not use anywhere near the full allocation. As you can see, this is the IANA table. And for DTLS, the requires coordination, which means a potential conflict with 7983 is in the 0 to 19 and the 64 to 255 range. But 25 to 63 are currently unassigned. 25 will be assigned by DTLS 1.3, but basically a large portion of the DTLS space from like 26 to 63 is currently unassigned. So that's something to keep in mind in the slides that follow. Next. So since the presentation at IETF 100, the idea of using Quick and WebRTC has gained some traction. We have a JavaScript API spec under active development in W3C. It's matured a lot from implementation experience and has been following the Quick Transport doc, adding support for unidirectional streams as an example, and lots of interest in it. And some implementations are coming. There's been an intent to implement filed. There are people experimenting potentially with additional scenarios like carriage of media. So quite a bit of interest here. Next. So why can't we declare victory? At IETF 100, we basically said we would document this purely in the Quick spec. What's wrong with that? Well, history shows that if you have an undocumented algorithm or agreement, something is likely to go wrong over time. One of the things that can go wrong is if you don't document requirements in the IANA registries, like what we have for DTLS, someone could assign a code point and step on something without realizing it. Another problem is that, and I think more relevant here, is that if you have an undocumented algorithm, it's likely, particularly one that changes with different drafts of QUIC, it's likely to exhibit interoperability problems. And as I'll describe, the original proposal from IETF 100 needs to change a bit. And if we don't write this down, eventually some developer is going to find some old set of slides, go implement it, and something bad will happen. And that's particularly true since we have trials approaching with this. And once those are out, people will start to depend on multiplexing. You've got WebRTC, which is being deployed all over the place, 700 applications, 1.5 billion users. So it's very easy for something to get out in the wild and be very difficult to recall if it's broken. And so at this point, if there are problems with multi-hosted support, that would have consequences. And I believe I'll try to make the argument that we need to document this in an RFC 7983 DIS, just so developers know how it all works. We also go over it very carefully and understand exactly what we're telling them to do and go through the normal process. Next. So this was particularly brought home to me in going over the transport draft version 16 and comparing it to the 08 and trying to figure out what changes were needed in the demultiplex algorithm. The long header didn't change, and the type values, field values are pretty much the same. So that was more or less as it was in Colin's presentation. So at least that part is good. Next slide. But I noticed a few things that I had to scratch my head about. One is that there's a stateless reset packet with a key phase bit. So the actual short header has changed. There was a C bit in it that we talked about at IETF 100. It's now a K bit for key phase. And this brings up the possibility of potential overlap with DTLS, namely code point 48. As I described earlier, it's not actually, 48 is not actually an allocated DTLS code point. So even with DTLS 1.3, nothing bad would happen there, but it does impinge upon the DTLS space as allocated in RFC 7983. Next. So the short packet header has also changed, and there's now a K bit and some R bits which are set randomly. That generates code point values 48 to 55 with a potential overlap with DTLS. For a K value of 1, that's in the range 112 to 119, which was taken into account in the previous IETF 100 proposal, so that's not an issue. But again, we have this potential overlap with DTLS, which is not documented currently in RFC 7983. Next. And finally, there is a version negotiation packet that's in section 17.4, which has the high order bit set to 1, and then a bunch of unused bits which are set randomly in the server, and that generates values 128 to 255, which can overlap with RTP and RTCP. That's not a big problem because if the version field here, the next 32 bits, will be 0 for QUIC, so you can check that and realize that it is not, in fact, RTP and RTCP. It's a QUIC packet, but that fact was also is not something that's in 7983 or in the IETF 100 proposal. Next. So based on what I've just shown you, here's what I think the revised demultiplex proposal looks like. And again, this is something I think it has to be double or triple checked, but here's where I think it ends up, which is pretty similar to what came before, except that code points 48 to 55 would be forwarded to QUIC. That would be from the short header. You'd get 112 to 119 also from the short header, potentially for different values of the K bit. You would forward 128 to 191 to RTP and RTCP, but only if the version field, the next 32 bits, was not 0. And then I think 250 to 255 would still go to QUIC, and that's the long header. So a little bit different from what we had at IETF 100. I think still workable, but a little bit different, and also some additional checks that have to be done from what we had there. You can't just look at the first octet.
Hey, Bernard.
Next. Yeah.
Mosinati, well, one question on the version check. So wouldn't that overlap with the timestamp in RTP?
It would.
Was timestamp 0 invalid or somewhere becoming invalid?
0 is valid.
So how is that? It's a pretty poor heuristic, I think, if
Yeah.
to rely on.
Yes. Good point, Mo. This is why I think we'd have to discuss this to double check this. I think that there would be if you potentially had a timestamp of 0, you could make a mistake. There might be something else we would have to look at in that case. I guess the point I'm trying to make here, Mo, is that this is worth documenting and reviewing in the IETF rather than leaving this to folklore.
Absolutely.
For that exact reason.
And one other question. So, sorry, I forgot where things landed on the multiplexing draft. I thought there was discussion of squeezing the turn range to something much narrower. That didn't happen. It's still the full range in the multiplexing draft, in the RTP multiplexing draft. I thought there was talk of squeezing the turn range into something very narrow, even narrower than this in this 64 to 79.
Well, I don't recall that. That's certainly something that again, if we had a draft to actually talk about, we could do, and might well be worthwhile. So I guess that would be another reason to actually have a document and put it through the process so that we look at it and understand exactly where we stand.
Hey, John, thanks. I mean, I thought that at some point we said that, I mean, turn needs to be demuxed from, the turn channels need to be demuxed from stun, but other than that, you always know, is this a packet coming from your turn server or not? You know,
That's true as well.
If the IP import is coming from your turn server, you treat it as turn or stun. Otherwise, you don't. It can't be a turn channel. So I think that's a separable problem. So the comment I was going to make, sort of the general comment, Bernard, is that.
So I think the problem here is that we're thinking about it only from one entity's viewpoint, and there's maybe multiple entities that are concerned about this and want to do. Like, it may not actually be the receiver that cares about this. There may be stateful boxes on the path that that also want to understand what this is, and so if they now they have to know what the turn server IP import is to in order to know that it's turn. So I think this adds a layer of complexity for demuxers that aren't necessarily the final receiver. So I think it's better if we had a turn range that's well defined, that fits narrowly within the quick and RTP, RTSP, DTLS demux strategy.
Yeah,
that'd be preferable to me.
But I think to your point is that nothing I've shown here would make that impossible.
Yeah, I was actually surprised that turn was still allowed 64 to 79. I thought it was already squeezed down to something.
Yeah. Well, again, I probably have to triple check the quick document, but my understanding is that the overlap there has been reduced. But again, it requires triple and quadruple checking to make sure we understand all the ranges that can be done here.
I think the most important thing is we need to update the multiplexing draft to say that quick is RTP v3, and
or something.
Well, that's a whole nother thing which we'll talk about in the next presentation. But next, yeah.
Yeah. So what I was going to say is I feel like quick sort of there's what the current quick v2, I guess they're calling it now, is doing, and then there's what quick is guaranteeing for the future, which is the wire image. And I feel like this needs to be more what is the wire image guaranteeing, which might mean we need to talk to, I guess that's Martin Thompson, about to sort of say, what is he willing to say that quick is going to guarantee, not just in this version, but in all future versions of quick?
So in general, the agreement was that we were only talking about quick version 1 because by definition, the quick version numbers, if you go to a different version, negotiate a different version, you can change almost anything. And I think the thinking was basically that in version 2, who knows what it could do, so you can't really, make absolute promises about it. But so my recommendation would be to just try to document what goes on in quick v1, maybe not call it quick, but just quick version 1 and make that clear. So that we would understand exactly what the promise was. But I think that's also one of the arguments for documenting something. If you write something down, then everyone knows exactly what you're agreeing to do or not agreeing to do, and what exactly the advice is. My overall impression from reviewing Transport 16 was that just leaving this as folklore would be potentially very dangerous, like leaving a gun around that someone could shoot themselves in the foot with. And also, in particular, there might be changes to the TLS content type registry. For example, to cite values 48 to 55, which have overlap as requiring coordination in RFC 7983 bis. Not that they're likely to get allocated anytime soon, but just to make it clear what the status is.
All right, so do people agree this is worth doing? And I guess since 7983 was ABT Chorus, we should take it on as well, even though obviously it's a coordination across a wide variety with the IETF. And are the people who gave this presentation willing to submit a draft to do or the authors of 7983 or whatever, submit a draft updating this, Bernard and Colin?
I'm willing to do it. I don't know if Colin's here, so I'll let him speak for himself.
Colin Perkins, I don't have time to lead it, but I will certainly help if someone else is leading the effort.
So my advice would be submit a draft for, I guess, progress the next meeting, and then, or even sooner. We don't have to do everything at meetings, but submit a draft, and we will take a look and decide at that once we have a draft to look at whether we want to adopt it as a work item to do the best. Any disagreements? All right.
Thank you.
Okay.
Do you have to continue?
Are we out of time?
Yep.
Oh, we're out of time, so I guess, Jörg, you don't get to talk after all. But if you want to give a very quick sort of.
Okay.
Sure.
Yeah.
Okay.
I really want to be quick.
Here's it work. No, this one. Okay.
Yes. So.
This way you don't have to ask me to change slides for you.
Okay. I'll try to see if I can operate this one. Okay. So hi, I'm Jörg. This is a very quick heads up about a piece of work that Colin and I put together in response to all the ad hoc engineering work that has been going around RTP and Quick and running real-time streams over Quick. So this came from a paper we submitted to a workshop that's going to be published in December. We sent this to the mailing list, and suddenly people came to us and said, "Oh, don't you want to say something in AVT Core?" So here we are. This is why we don't have a draft yet. There's going to be one at some point, hopefully not too distant point in the future. The main observation is that many people have been looking at different flavors of running RTP over Quick. We are guilty of a draft outlining some of the ideas ourselves. But quite a bit of these have been done more or less in an ad hoc fashion. Streaming media probably works reasonably well, but interactive media, we had all kinds of different suggestions in the past. This is surely not an exhaustive list, ranging from mapping each video frame in a conversation to an individual quick stream, so opening 30 frames per second or something like that, or 30 streams per second, to avoid persistent retransmissions because the video data might get stale at some point, limiting retransmissions at some point. Then we have most recently a datagram proposal that doesn't do anything but just emulates UDP over Quick, with a little bit of a framing over the Quick streams. And what we did is we wanted to take a step back and actually look back at what RTP has been doing. And so we came up with this paper, which has a good reason because it doesn't advance anymore.
No, I think somehow there's something there's something weird about how the slides got converted, I think. Let me see if I can.
Just scroll to the next one.
Trying to.
So one of the reasons that we didn't start off with an ID is because you can't really do really sophisticated tables in ASCII art so easily.
It might be truncated.
Okay, so in the slides that will be there, there is a table with 21 features that describe what RTP has been doing, how this is current, how this could be addressed on top of Quick, and how that could in the end be. But the fourth slide is here. Why is the fourth one here, but not the third, or the last one, but not the one before? Anyway, so we have a big table. Yeah, there's a table. I see
I
it.
think maybe it's just there's something about this slide which is taking a very long time for it to render.
Oh, it's PDF in PowerPoint. Ooh.
Oh yeah, maybe did you use funny fonts and so it's trying to. Whatever.
Times Roman isn't a funny font.
I don't know. Anyway.
So anyway, so you get the idea. We went through a bunch of different properties that are features that RTP provides, looked at how this could be mapped into Quick and how one could put this into a.
I tried to full screen it. Sorry.
No, don't worry. Anyway, it's too long to go through this anyway. So take a look at that paper, at that table. Out of this analysis, we try to come up with a minimal feature set that one could use as a strawman proposal on how to co-evolve RTP and Quick. Next, now I can probably advance. And we call these RT streams that have minimal ADU sequence numbering rather than byte offsets. We have media-specific timestamps, as we know from RTP, ways to control retransmissions on a per-channel fine-grained basis, and then we have more detailed reception reporting, which is what we figured would be the useful common transport layer features that are worthwhile adding to Quick. We also have a wall clock time synchronization for interstream, what RTCP usually does, by means of a separate method or packet type, and then we push all the rest to the application layer. The nice thing about this is that most of these things are optional. So if you leave out everything, this reduces nicely to the datagram style service that we have right now, except that it doesn't use the strange framing. So this is a heads up because we feel that probably quite a few endpoints will be implementing Quick, and they will also want to do real time at some point. And so we want to come up with something that makes sense in the long run. We're going to have some discussion around this topic at some point. Thanks. Questions?
We don't really have time for questions, so.
Thank you.
All right. Well, thank you all, and
See you in Prague.
see you in Prague and around the meeting. Anybody didn't get a blue sheet?
Proceed?
Blue sheet, anybody?
Yeah.
Oh, that's right.
Blue sheets?